So, Avantika, a balloon is inflated with helium gas at room temperature of 25 degrees Celsius and 1 bar when its initial volume is 2.27 liter and allowed to rise in air. As it rises in the air, external pressure decreases and the volume of the gas increases till finally it bursts when external pressure is 0.3 bar. So, let us note the conditions: 25 degrees Celsius and 1 bar. Initial volume is 2.27 liters. It starts rising. When it starts rising, see, please try to understand what happens when this balloon starts rising. Let us try to understand. So this is say surface. Now when the balloon is at surface, uh, approximately around 10 kilometers of atmosphere is above the balloon. One thing, any doubt about this? One thing, any doubt about this? So 10 kilometer of atmosphere is above the surface of Earth, approximately. So the balloon is here. When the balloon is here, the pressure is 1 bar. Now when it starts to rise, the pressure, let us assume that the balloon reaches here. Now here, only this much amount of atmosphere would be above the balloon. So that is why the pressure would be lesser. CB good out. So the pressure has decreased. What is the limit at which the volume of the balloon can stay inflated? Now see, they haven't talked much about the temperature. Because they haven't talked much about the temperature, so what we will assume is that the temperature would remain CB constant. And when the temperature remains constant, which law is applicable? Boyle's law is applicable. So BT का bike. So Boyle's law is applicable. And what is Boyle's law? Yes. So as per Boyle's law, the number of moles and the temperature should remain constant. So P1 V1 would be equal to P2 V2. Any doubt? Now, the this is condition 1. So this is P1, this is V1, this is P2, and this would be V2. Any doubt, CP? So what is the limit at which the volume of the balloon can stay inflated? See, it bursts at 0.3 bar. So that is why whatever volume you get here would be the answer. Any doubt? So 1 bar into 2.27 liter is equal to 0.3 bar into V2. So if you solve this for V2, your V2 would be 2.27 upon 0.3. So when we apply P1 V1 is equal to P2 V2, so 1 bar into 2.27 liter is equal to 0.3 bar into V2. What we need to remember is that this V2 would come in liters because this bar and this bar will get cancelled. So no unit conversion is required. So V2 would be equal to 2.27 liter upon 0.3. And if we solve this is the answer that we will get 7.567 liters, and which is the final answer. So see, what we need to understand is because they haven't talked anything about the temperature, so we'll assume the temperature to be constant. But try to compare this question with this question. At 25 degrees Celsius, 760 mm Hg, gas occupies 600 ml of volume. What will be the pressure of the height where temperature is 10 degrees Celsius and volume of is 640? So if you see here, the pressure is changing, the volume is changing, as well as the temperature is changing. All the three are changing. But if you observe that the number of moles remains the same. Just to see any doubt. So you need to be very careful whether one thing is constant or all the three are changing. But if the question can't be done, so for example, in this case, they haven't talked anything about the temperature in the second state. So that is why we just assumed that the temperature was constant. Any doubt? Mr. Vantika, any doubt?
No, no.